Okay, today what we're going to do is we're going to take some notes over empirical and molecular formulas. Okay, so what is an empirical formula? This is a formula giving the proportions of the elements present in a compound, but not the actual numbers or arrangement of atoms. Okay, and it's the lowest ratio of subscripts. So what you can't see on here, they didn't show up, is there should be a dot here and a dot here, and there's just an S after the atom, so atoms. Okay, so an empirical formula is if we were to look at, it would give us percentages of each of the elements in a compound, and we go through some simple math to figure out the lowest ratio of subscripts for each of the different elements, and then we'll relate it to molecular formula a little bit, and that will help us to get the exact ratio of subscripts, not the lowest ratio. Okay, this will make more sense as we go through. Okay, so steps to calculate this. I'm going to make this just a little bit smaller here. Oh, I didn't mean to close it here. I'm going to make this that's not what I'm looking for. Sorry, guys. Okay, so the steps to calculate an empirical formula. So in calculating the empirical formula, we always assume we're given 100 grams of a sample. So when we're going to be working with percentages, and so we have to convert percentages to grams. So the percent composition of each element can be used as the mass in grams. This will make sense when we do an example. So step 1, we're going to convert the grams given to moles, dividing by the atomic mass of each element, and we're going to use a rounded atomic mass with the answers. We're going to have at least 4 significant figures. Okay, so we're going to go 4 digits after the decimal point if we have that many digits. Okay, so they have an example here of 75 carbon and 25% hydrogen. If we were going to look at those percentages and put them into grams, that would be like saying for our sample, we have 75 grams of carbon and 25 grams of hydrogen. Okay, then the next thing is we're going to determine the mole ratio. We're going to divide each number by the moles of each number of moles by the smallest number of moles. If our answers are not whole numbers, we may have to multiply by some factor to make them whole numbers. We don't just round. Again, this will make sense as we go through and do an example. Feel free to pause this if you need more time to write. Okay, when we get our answer, if we're going to take a number, so like here's our number, we're going to divide it by the lowest molar mass, so maybe it's 0.33, and we get an answer of 2.6, okay, or 2.62 or something like that. These are our rules for rounding, because we need this to be a whole number. Okay, so if it's greater than 0.8, we're just going to round it up. If it's less than 0.2, we're going to round it down. Then if it's something in between, whatever it's closest to is we're going to multiply. So if it's 0.2, we multiply it by 5 to get a whole number. If it's 0.25 or 0.75, we multiply it by 4. If it's 0.33 or 0.66, we multiply it by 3. And if it's 0.5, we multiply it by 2. Okay, again, this will make more sense as we go through one. Okay, and then our third step is we're going to use ratios as the subscripts in the formula. These elements usually appear in the problem in the same order that they should appear in the formula. Okay, we're going to do this one together. Okay, So the example is if we have 32.4% sodium, 22.5% sulfur, and 45.1% oxygen, and we're trying to figure out what the empirical formula is. So the first thing that I'm going to do is I'm going to take each of my elements. So the first one I have here is sodium. So I always write it so I know what I'm working with. And it says it's 32.4%. So we're going to do 32.4, and we're just converting this essentially to grams. Okay? And we're going to divide that by the molar mass of sodium as a rounded number. So if I look on my periodic table, sodium has an atomic mass of 22.9898. So we're just going to round that to 23. And we know that's grams per mole. And when I calculate this, I get 1.4087, and we're going to keep a label of moles just for now. Okay? Because we essentially canceled out those grams. Okay? Now I'm going to go to the next one, sulfur. 22.5 grams divided by, I look at the atomic mass, it's 32.065, so that's going to round to 32 grams per mole. And so when I calculate, I get 0.7031 moles. Okay? Then my last one, I've got oxygen. And it says 45.1%, which we're going to just convert to grams, divided by the mass. It's 15.9994, so it's going to be 16 grams per mole. And this gives me 2.8188 moles. Okay, so I just did the first step. All I did was I converted this percent to grams, and then I divided it by the atomic mass to get a number. Okay, now what I'm going to do next is I'm going to take and divide all three by the lowest number. Okay, so like I was saying, now what we need to do is we need to take this number and we have to divide all three of them by the smallest one. Well, my smallest one is this one right here. Okay, that's my smallest number. So that's what I'm going to divide them all by. So I'm going to divide this one by 0.7031, 0.7031, 0.7031. Okay, when I do that, I know that this number divided by itself is going to give me 1. When I do this one, I am going to get a number that's going to give me 2. Okay. When I do it, I get a little bit over 2, but it's less than 2.2, so I just round down. Okay. Then for the last one, it's going to round to 4. Okay. Again, we can follow those rules if we need to, but these all fall into the where we can round them up or down. Okay. So they're either 0.8 or larger or 0.2 and smaller. Okay. So the empirical formula for this is going to be Na, and these numbers are just my subscripts. So to be Na2 SO4. And that's my empirical formula. Okay. I know, a little bit confusing, lots of math, but not super hard, I don't think. It's kind of nice we get to round the atomic masses instead of having to use all those decimals. All right, so then molecular formula is next. This is all about ratios. If we know the empirical formula, we can find the molecular formula. So the example they give here, we have octane, C8H18 is octane. Its empirical formula is C4H9, meaning lowest ratio. So if we divide it by the common factor of 2, okay? So the empirical formula just gives us the smallest ratio of all the different molecules or elements that make up that compound, whereas when we're looking at a molecular formula, we're looking at an actual compound like octane or propane, okay? So these pictures down here of the hamburgers are kind of just to get you to see. So empirical formula, Down here we have a bun and a hamburger right here, okay, which equals this 1-to-1 ratio, 1 bun to 1 patty. Over here with the molecular formula, we've got 3 patties, we have 3 buns, making a triple burger essentially, or 3 burgers, and so our molecular formula would be B3P3, okay? We're just taking that empirical formula and just multiplying it by 3 to get an actual compound of something, okay? That's really all molecular formula is. So the steps to find the molecular formula: first we have to find the empirical formula, then we divide the molar mass of the actual compound by the molar mass of the empirical formula, and we'll do that so you can see what that looks like. And then we multiply the subscripts in the empirical formula by your answer that you get in step 2, and then once we do that multiplication, we'll get the molecular formula. Okay, so we're going to try one of these. So it says the empirical formula for a compound is CH2O if the actual chemical compound has a molar mass of 180 grams per mole. What is the molecule formed for this compound? So they gave us our empirical formula. We don't have to find it. Sometimes on these kind of problems, they'll give you those percentages again, and you'll have to figure out the empirical first. Okay? If we're finding the molecular, they're always going to have to give us this molar mass. Okay? Somewhere in our equation. All right. So how we're going to do this, we're going to take the molar mass, which is 180 grams per mole, and we're going to divide it by the molar mass of the empirical formula. So we have 1C. So we're just going to round those molar masses. So I'm looking at my periodic table. Carbon has an atomic mass of 12 grams per mole. Again, we're just rounding to whole numbers. Plus I've got 2 times hydrogen, which is 1 gram per mole. Plus I have 1 oxygen, which is 16 grams per mole. Okay, when I add all these up, so I have 12 plus 2 plus 16 gives me 30. So essentially I'm taking 180 divided by 30 and I get 6. So all I'm going to do is take 6 times my CH2O. So that 6 is just going to be multiplied for all 3 of these, just like we do in math. So it'd be C6, 6 times 2 is 12, so it's H12, and then O6, and that is my molecular formula. Okay, we're going to do a lot of practice with this. I'm going to give you, there's a couple of sheets that if you came and saw me beforehand, you have, or you can get them when you're back in class to do some practice. The answer keys will be on Schoology, and that way you get in the habit of doing this. It's not extremely difficult. It's just a lot of writing and figuring out whether you're figuring out empirical or molecular formula and doing all of the steps. Okay. If after watching this video you have questions or need more help, please make sure you're touching base with me and I can help walk through a couple more problems. All right. Thanks.